Good morning. My name's Hugh Robinson. I'm the Managing Director of StepX, the organisers of the DataCentres Ireland conference and exhibition. I would like to introduce you to the third Data Centre Leadership webinar hosted by DataCentres Ireland. Today, the panel will discuss data centres and heat networks under the title Heat Close to the Edge. The backdrop for this discussion is the statement by the European Commission that as part of the Green Deal is that data centres can and should be carbon neutral by 2030, with an underlying threat of regulation or enforcement actions to achieve this goal. This panel discussion is led by John Booth, Managing Director of Carbon 3 IT and the Catalyst Project Lead at Green IT Amsterdam. Catalyst aspires to turn data centres into flexible, multi-energy hubs which can sustain investments in renewable energy sources and energy efficiency. This webinar is approximately 1.5 hours long. However, during the first 15 minutes, there were some local connectivity issues, which meant the panel's moderator, John Booth, was unable to connect consistently, and I had to step in to facilitate the debate. Notwithstanding my input, I hope you enjoy the discussion. So let's now meet the panel.
Yes, hello. Good morning, everyone. My name is Alessandro Provacci. I'm head of the DAC Plus technology platform here at Eurotem Power. Eurotem Power is the European District Heating and Cooling Association, and let's say that at DAC Plus we deal mostly with all the innovative part of that. So waste heat is definitely, let's say, a very big topic for us. Thank you for the invitation.
Okay, that's me next. Eric Barendsen. I'm Senior Policy Officer at the Dutch Data Center Association, responsible within the this group for energy and sustainability regarding data centers, and heavily involved in the discussion in the Netherlands and Europe about reusing the residual heat of data centers in district heating systems. So over to John.
Hi, yeah, I'm John O'Shea. I'm Energy Systems Analyst with Codema. So Codema is the energy agency for Dublin, founded in 1997 as a non-for-profit, and we act as the energy advisors to the four Dublin local authorities and help them achieve their kind of energy efficiency and CO2 targets. And I guess my work then, I'm primarily working in the district energy and energy master planning areas. So everything from initial identification of district heating opportunities to design of networks and procurement and contracting. And I suppose the kind of most relevant project for today is our project in Tella, so the Tella district heating system, which is being developed by South Dublin County Council, and is utilising waste heat from a data centre to heat local public and residential buildings. That's me.
Okay, so my name is Eero Lindqvist and I work in Telia Finland. Telia is a new generation telco operating in the Nordics and Baltics mainly. And we have three business areas, so consumer business with mobile services and media, TV, video on demand, gaming. B2B services with, let's say, networking, IT.
So, Ellie, you want to take over?
So is it Alan?
Yeah, probably. I think we just lost Eero.
Yeah, I keep dropping out as well.
Apologies for this, but Alan, if you could introduce yourself and explain how you're involved in heat networks.
Okay, hi, I'm Alan Beresford, MD of Eco Cooling. We specialise in fresh air adiabatic cooling of data centres and telco. So I've deployed probably about a quarter of a gigawatt of fresh air. But specifically, what's most relevant for today is I'm lead consortium member of the Bowden type data center, the most efficient data center in the world, maybe, where we're doing a lot of work on heat recovery. So I'm going to share some of that experience with you today.
Wonderful. Thank you very much for that.
So my name is Rolf Brink. I'm CEO of Asperitas, one of the leading immersion technologies in the industry. And one of the things that we're specialized in is high availability and heat production directly from IT equipment, in addition to running and being the founder of Asperitas as well. I'm also leading the immersion group within the OCP Advanced Cooling Solutions environment, where I'm also fairly active regarding heat reuse and maximizing the potential of liquid cooling.
Okay. Now, in the absence of John, I apologize. Did Eero introduce himself?
There is maybe me.
Yes.
Thanks for inviting me. So I'm Nicolas Saint-Héran, Innovation Manager at Carnot Computing. We are SME created in 2010. We are based in Paris. Now almost 40 people are working at Carnot, and we recently signed the last fundraising of 6 million before the lockdown. So we are really happy to share about it and explain that we will really grow in the next few years. We are an edge cloud provider that provides its computing capacity through a fully distributed data center. The novelty of our data center is that it is designed to reuse all the waste heat that it produces. So this is why we are here today. And also because we are involved in the Catalyst project regarding the energy flexibility toward the electricity and the heat grid.
Thank you very much. Now, in the absence of John, fortunately, he very kindly put forward some scripts. What I'd like to do is start off with the first question that John had put in mind. So his first question was potential. Can we use waste heat from data centers? If you could give us a couple of minutes, each of you, on your thoughts on that. Starting off with Alessandro. Perhaps you'll give us a strategic perspective.
Yeah, thank you. Yes, we can. I think, maybe first of all, I think it's discussions like that are very useful because I think that our two sectors, at least I can say from the district heating part, I feel sometimes we don't talk enough to the potential waste heat provider. So in this case, to the data center operators. I'm often in several meetings where we say, yes, waste heat from data center is a very good idea. And frankly, there is almost maybe no data center manager or operator in the room. So there are just district heating people. So this is very, very good platform. The other point, so I'm based in Brussels. I deal a lot with the EU policy. And yes, we see coming, we see that the data center are going to be, let's say, more at the center of the policy discussion because the priorities of this European Commission are the Green Deal and also the digitalization. So for both priorities, data center are key. I also say that in July there was an important document that was a strategy, but so not a binding, let's say, legislation, but that will probably come soon. A strategy on energy integration. So again, the use of waste heat and data center were quoted, were included several times. So we expect, let's say, a sort of pressure to come, at least for let's say the EU member states. Already in 2018, there was for the first time we saw a target for each member state that they need to raise their share of heating of renewable, but also of waste heating of 1.3% every year. So member states are gonna look into waste heat. They're gonna start mapping it better, and they're gonna most likely look also in the data center. So I stop here.
We can't hear you.
Sorry. Eric, sorry, what was your view on the policy?
Yeah, thank you, and good morning to everybody listening in and viewing in on this webinar. I think we must and we can. In order to reach the climate goals, we need all sustainable heat sources we can find, including data centers, but many others. I mean, data centers will not be the only heat source which will be able to heat up the whole European built environment. But given that data centers run on electrical power, most of data centers run on green electrical power, it is really a waste to blow this energy basically into thin air. So yes, we must and we can. But very important is that we need to adapt the policies by governments. The data center residual heat needs to be seen as a sustainable heat source. And I've seen many cases where actually the policies and the calculations and the different calculation documents made by governments do actually not recognize data center residual heat to their full extent. For instance, in the Netherlands, residual heat of data centers is being seen as industrial waste heat, which means that we still have to calculate a small part of a carbon footprint, which is actually not using the data center residual heat to the full extent. Data center residual heat, though of medium to low temperature, does improve the efficiency of heat pumps enormously, given the fact that it's anything between 30 to 50 degrees. And by this, saving a lot of strain on the electrical grid. So it helps on two phases. It helps to reach the climate goals, but also actually to reduce the energy required by individual households to heat up their housings. So I would like to leave it at this.
John, over to you.
Yeah, I mean,
hi. Where did we get up to?
Sorry, the two Johns. So I was introducing John O'Shea, but I'm also welcoming you back, John. So I'm going to turn myself off and leave the rest to you.
Where did we get up to, by the way, before we?
John O'Shea was going to talk about planning and infrastructure.
Yeah, just on the potential. Yeah.
Okay, fair enough.
Yeah.
Over to you, John.
Thanks. So yeah, in terms of potential, I mean, 100% yes. There's a lot of potential there. And I suppose for Dublin, we won't have far to go for evidence of that with the scheme being developed in Tallaght and work due to begin in the coming weeks. I suppose the kind of key components in realising that potential are to ensure that district heating networks are developed in areas where there's high enough heat demand intensity, to kind of make the networks viable. And then I suppose secondly, you're looking at the potential for low carbon heating sources in the same areas. Like for example, like Dublin, data centres in Dublin represent a significant proportion of the heat source mix in that area, and could potentially heat 250,000 homes in the Dublin area. And this kind of heat resource is likely to increase in the coming years as well. With these projections on the increased number of data centres on the grid that EirGrid have provided. And I guess one of the kind of key success factors for the Tallaght scheme was the planning requirements that were in place. So the data center was required to carry out an assessment of the waste heat potential from their data center. And if a data center was planned or constructed in the locality, they were also required to install the kind of heat recovery equipment to bring that heat to the site boundary. And I'd say that the data center in Tallaght really kind of saw the potential in this, and even kind of went a step further, I suppose, and provided a site for the district heating network's energy center as well. I guess some of the other areas, I guess planning in terms of scheduling and all that, you don't want to miss out on certain customers in the area, so kind of getting early engagement, to ensure they're not kind of locking themselves into kind of fossil fuel heating systems, for another 15 years. And installing that kind of heat recovery equipment is obviously easier during the construction phase. So early engagement with data centers in that regard is key as well. And also there's further opportunities as well in kind of identifying trench sharing opportunities, for example, with fiber optic cables. There's a cost reduction associated with sharing the civils costs for both those items. So yeah, that's me.
Okay. Yeah, that's pretty good. Eero, is the connection of data centers to district heating systems mandatory in Finland? Eero, I think you're on mute. Oh, Eero's dropped out, I think. Let's move on to Alan. So, Alan, you've been involved with the Boden Type 1 data center project up there in a very cold part of the world. Can air provide viable heat for district heating systems?
I am not sure yet. And what we've done as part of the Boden Type data center is we've actually taken a step beyond just cooling the IT equipment, and we've taken control of the cooling of the chip cooling of the IT equipment. That started with John Summers and the Open Compute, and we've got a range of ASICs, GPUs, and Open Compute equipment. Now, what I've found is that if we concentrate on chip temperatures and we have reasonable heat transfer, then suddenly we can get hot aisle temperatures of 50 or 55 degrees centigrade. That then makes air a more useful commodity for the next stage of heat recovery. As it stands now, with air coming out of a hot aisle at 30 degrees centigrade, in my opinion, it's too low grade. We need something additional, like the Stockholm data parks, where they use heat pumps to elevate the temperatures to be useful. My answer to you, John, is if we can look at this in a holistic way and exploit the maximum temperature of chips and the mechanical engineering of getting air through heat exchangers and create air at 80 or 90 degrees centigrade, then it would be possible.
Carrying on that theme, and I will keep stepping in for John whilst he's there. Eero, I don't know whether you can. You're back and can speak this time. You were on mute last time.
Hopefully.
Wonderful. I know that John was going to talk to you and sort of say, is this mandatory, the heat recovery in Finland?
Can you hear me?
Yes, we can hear you, John. So heat recovery is not mandatory, at least for time being, in Finland. And to my understanding, there are no such regulation planned for the coming years. But there are some incentives. So the next year budget promises that if data centers and heat pumps are connected to the district heating system, then you will get the lower industrial electricity tax. So all the electricity you use will be on the lower tax regulation, and that will give you something like 1.7 cents per kilowatt hour benefit. So I think that will make it more interesting for the data centers to be connected into the district heating system.
Okay, that's quite interesting. So, Rolf, what's your opinion on this? And I know that you have an opinion.
Oh, really? You think so? No, of course, yes. I absolutely do have an opinion on this, and I think Alan hit the nail right on the head, right, with referring to the chip temperatures and getting access to that heat potential that is on the chip itself, because the chips are the really hot components that require that cooling or can generate heating, depending on which way you look at it. Now, one of the inhibitors with air cooling is the fact that you end up with a high temperature difference between the chip and the medium that you're cooling with, and even air is very limited in how far you can transport it without significant losses. So in order to utilize air cooling for heat reuse, you're going to need to transfer that thermal energy into a liquid medium to be able to transport it, to feed it into a district heating system, or to make it usable in any possible way. So this is where liquid cooling in general already comes in, and with the different cooling techniques that are now being adopted, that are now breaking through in the industry, everywhere around us, I think immersion is one of the key differentiators, because immersion is a holistic way of cooling IT equipment. Simply put, the entire IT equipment is literally submerged into the liquid, and every watt of electrical power is being converted into heat in some way, and that heat has nowhere else to go than into the liquid. So that means you capture, technically speaking, you're just capturing 100% of the thermal energy, and then you need to transfer that into a liquid system, which can be utilized to distribute that heat, and that's a liquid to liquid transfer, which means that you get, first of all, a holistic approach towards IT equipment cooling, and second of all, you have the best medium to utilize for transferring that heat and then moving it onwards to transport that heat. Now, one of the other big upsides of liquid cooling is the fact that you do get direct access to the high heat rate potential of the chips themselves. Yeah, so if we're looking, this is something that we do a lot of work with to see how far we can upgrade some of this heat. Now, with immersion, but it's also feasible with cold plate technologies, where you get that the chip temperature. One of the downsides with cold plate is that there still is the rest of the system which is not being immersed or not being captured, so where you still need air cooling for, where you still need to transfer that heat somehow. And that is something where immersion does make a significant difference.
Okay, that's a very interesting point. And I know that Nicholas from Querno, you use a very similar type of solution, but you've got a bit of a twist on it. So can you briefly explain your twist on the immersed cooling aspect, please?
Yeah, we share some of the principles that Rolf just detailed. But at Carnot, we decided to use some other techniques, but for sure they could be complementary, and they maybe could be used in different situations. So at Carnot, we think that when you consider the data center and you want to make it more sustainable, you can't just reduce it to the lowering the PUE to reduce the external consumption, such as cooling, for example, which is supposed to be the main consumption other than IT. So it's good, but it's not the full path to the sustainability. So we decided to work on the heat reuse, and we decided to design our hardware to produce the heat where it's necessary. So almost all heat produced by our devices are fully recovered and reused for useful purposes. So we do think that in the next years we should more think and communicate about the ERE, energy reuse effectiveness of the data centers, to go as far as possible in the sustainability, because the heat cannot just be a waste, and it should be a product, because a lot of energy in Europe and in France especially is consumed by other buildings that can be nearby or not. So it's important to consider the waste heat reuse. So at Carnot, we design mostly 2 or 3 products. The first one is the space heater. So we just add a really large heatsink, aluminum heatsink, that is directly connected to the CPUs, and we can heat a room or a living room, or especially housings or offices. Then we recently developed a boiler for domestic hot water, and we don't really use the immersive cooling as presented by Rolf. We decided to use cold plates. And yes, for sure, there is other problems that we have to deal with, but there is some technical solution that can be designed to recover almost all waste heat. And we get to about 95% of efficiency regarding some different parameters, but we can go up to 95%. What is important is that we install really our hardware where it's necessary to produce heat, and we produce the heat that is requested by the site. So it's we are designed to produce the right heat and the heat that is necessary. And now,
okay.
Sorry.
That's okay. So effectively, you don't need to use district heating systems per se, because you're distributing the data center load through a residential apartment block, and you basically have a server in each of the rooms, which is then providing the heat out to the users. And
yes, but
we've tested that in the Catalyst solution, haven't we?
Yes, in the Catalyst project, we just we worked a lot on the relocation of virtual machines to relocate the heat as well as the energy consumption. So it's the most important outcome for us in this project.
Okay. So as I suspected, there is a lot of potential, and we can use the heat, and there are already data centers that are using waste heat for offices within the data center itself, adjacent buildings, and in some cases into district heating systems. But I think we need to remove some of the blockages from a planning and design from a circular economy viewpoint. So this raises an interesting question. So what needs to be in place from an engineering and technical perspective? And I would like to ask John from Codema how that's going to work at Talet.
Yeah, well, I'd say firstly, the thing we'll require is the networks themselves and the heat recovery equipment to facilitate this kind of circular heating economy. I suppose the kind of district heating infrastructure itself is pretty straightforward in that it's a network of highly insulated pipes buried in the ground, that send hot water to the connected buildings. And I suppose, the easiest way to visualize it is just to think about the centralized heating system in your house, where, but rather than each radiator is a building. So if you kind of consider it that way, so you've got a centralized boiler and the pipes supplying heat to each. So it's quite a simple concept, but it does allow you to take advantage of a number of things. One being the diversity in demand, and the other being the economy of scale. So obviously if you've ever been in a supermarket and seen those 200-gram chocolate bars, you're kind of familiar with economies of scale. So you get kind of more bang for your buck. And I guess there's sort of an intrinsic flexibility in that system as well, which allows you to connect multiple different heat sources, for backup and redundancy. and kind of also facilitating, sector coupling where it can kind of act as a thermal battery and balance the electrical grid and provide, demand side response services, at a fraction of the cost of batteries, for example. I suppose in terms of what's needed on the kind of infrastructure kind of technical side, the kind of heat recovery loop itself is very important. So in the case of Tala, we have this loop which is feeding kind of high efficiency, large scale heat pumps. So they're 2-stage heat pumps, and then these heat pumps bring the temperature up to a usable level, as was discussed earlier. So for us, it's like 70 degrees in the summer to kind of meet with Legionella requirements, and then kind of up to 85 in winter because we have some sort of older buildings on the network that would be used to operating boilers, which would supply 85 in peak winter conditions, and that's all kind of weather compensated then. And then I suppose one of the other kind of large technical elements is the substations themselves in each of the buildings. So essentially, that's a heat exchanger that replaces the existing boilers that would have been there. And in our kind of business model, we will be sort of maintaining those. So the district heating company will maintain those. So we're kind of looking towards more of a sort of a heating as a service type model, where the customer themselves don't have to concern themselves, I suppose, with regular maintenance of these elements.
Okay, and having been to the Telia data center in Finland and seen the big pit that was installed to take the heat pump, there's a lot of infrastructure that's required to connect to district heating systems, isn't there? So Eero, can you just briefly explain how it works for your building in Helsinki, please?
Sure. So the first thing is, of course, that you must be located somewhere near the district heating network where you can connect to. And luckily, we are located in an area where we can connect to 2 different district heating networks. So the location is one. Then, of course, you need some, let's say, extra space for the heat exchangers and heat pumps. But basically, that's the infrastructure you would then, in other cases, use for your cooling system. So it's not too much extra that you actually need.
Okay, and Nicholas, what do you need in your Querno solution from an external point of view?
Actually, we don't really need extra infrastructure, except that in the building we have to, of course, provide internet connectivity and electrical supply. But we don't really need additional infrastructure. So what is important is that as we are producing the heat locally, it's easy to move and easy to reuse directly in the building, even if it's low-grade temperature. For the space heater, we have to provide some cablings, but it's enough. And I wanted to speak about the new low-cost data center we are dealing with. We hit a large warehouse where we locate small data centers that are bigger than the building we are used to equip, but it remains small data centers compared to the traditional ones. So we hit about 60,000 square meters with about 250 kilowatts of power. That is quite important, and it requires some space, but compared to the 60,000 square meter of the building, it's almost nothing. And then we just have to equip the room to connect with the heating system, but it's almost nothing compared to a large district heat network. And finally, we are also working on a district heat network because we can actually move the heat source wherever we want as soon as there is internet connectivity and enough power supply. So recently in Finland, we installed a small data center to heat to contribute to heat district network. And we are planning to have a larger installation in Paris in next year maybe. But yeah, it's something we are working on. It's different from what we have done before, and the economic model is different, but we can do it as well.
Okay, so effectively, the engineering is robust. It works. It's been around for some considerable time, especially in the Nordic region for district heating systems. We have central power station and heat producers, which puts water into a district heating system that's then boosted at various locations. So we know it works. But of course, if we intend to use the heat externally from a data center into a district heating scheme, or even for local use, there is a kind of question is what needs to be in place externally. So, Alexandro, the question I have for you is, should there be a blueprint or master plan for district heating system developed by city authorities, such as there is in the Netherlands?
Yes, we quite like the example of the Netherlands. The Netherlands has a quite strong plan to decarbonize heat overall, and so there is a clear framework at national level, and then but the plan itself is done by cities or by the local level, so which I find a good mix. In general, yes, I would hope that in the future the waste heat recovery will be increasingly included in the design phase of the cooling system of the data centers, either in new construction or in retrofits. Another example that, apart from the one of the Netherlands, is I don't know if you know the data parks in Sweden. That's also a different approach where the data center operators are able to build their data within these areas, and what is guaranteed for them is secure and redundant power supply and a connection to the fiber network, and is also close to the district heating. In general, what I would also like to say that within one of our EU project that's called Reuse Heat, we tried to map all the potential of waste heat coming from the data centers, and let's say one of the barriers is that the data center sector has a certain level of confidentiality, which was a problem for having access to let's say the quantity data at site level, that in some cases even meant the correct geographical coordinates of the data center, or also the power capacities or other aspects that are needed for the district heating to be able to engage in a dialogue.
Okay, that's to my mind, it really, there needs to be a master plan. So, and I know that the Netherlands has quite a structured approach. So, Eric, can you take us through the national Dutch spatial strategy and the local policies that are in place, such as the new planning guidance from Haarlem and EMEA?
Yeah, I can do that. Thank you. So I guess we all agree that from a technical perspective, it is not that rocket science. Really like the idea of Carnot, instead of distributing the molecules, distributing the electrons to where the heat is actually required. So yeah, all good examples and good innovations. So in the Netherlands, we are lucky that we actually have Amsterdam, which is seen as one of the major internet hotspots and data center hotspots in Europe, causing all kind of interesting challenges, like the load on the grid, the space available, etc., etc. So in the Netherlands, multiple cities or municipalities actually have decided to not restrict, but to set policies on data centers and actually manage their building permits based on certain criteria. One of those criteria is indeed be prepared to feed a local heat source, a district heating system. So most of the data centers actually in the Netherlands, which are retrofitted or are new built, do prepare for prepare the T pieces and the technology to be able to feed their residual heat into a district heating system. And actually, the policies of Amsterdam and Haarlemmermeer, which were early in the news in 2019 because they put a temporary stop on the data center builds or new builds, they have now lifted those restrictions again, but under certain policies, being the data center shall be prepared to connect to a district heating system. However, there are two challenges there, right? I mean, yes, you can tell data centers to that they need to couple or to link into a district heating system, but then the district heating system, like Eero says, needs to be close to the data center. And district heating systems itself do often face challenges from a business perspective or a business case perspective. So it's a bit of it's a twofold challenge that we're all facing. First of all, the business case of the district heating system itself, that needs to work. And secondly, the residual heat of a data center also needs to be, from a political point of view, needs to be seen as very energy efficient, because after all, residual heat of a data center fed into a district heating system needs to, at the end, help the investors of buildings to reach their efficiency goals, which are also set in the Netherlands. I mean, every building shall have a certain efficiency number, which can only be achieved by using natural resources to either heat up the systems or use sustainable energy. And certainly for high raisers, where these norms also apply, you see that many of those high raising buildings actually will not be able to generate enough sustainable energy by solar panels or whatever, that they actually need sustainable heat sources to heat up the built environment. So yeah, it all comes nicely together, but we are certainly in the Netherlands still seeing some, I would say, discussions on the valuation of residual heat of data centers, and on the other hand, the actual business cases of district heating networks.
Yeah, I agree. Okay, so John from Kadima, should planning departments be planning for the widespread adoption of edge DCs and potentially capturing their heat for adjacent buildings, the heating of traffic junctions in inclement weather, and things like bus shelters, etc.? Should there be a kind of edge master plan? And that's for John.
Yeah, well, I'd say that, within the planning departments and the councils, there's kind of a whole range of issues that need to be addressed through their development plans, including things like provision of housing, but providing, affordable, low carbon heat for citizens to warm their homes is definitely something councils are very interested in. And also developers are interested in for compliance with building regulations as well. We often get calls from developers asking when the district heating network is going to be completed, because it's kind of a more cost-effective solution for them than installing individual heat pumps in apartments. I'd say that it's planning for district heating is kind of coming more to the fore. So the Eastern and Midlands Regional Assembly have a regional policy objective that requires planning departments to carry out feasibility assessments for district heating and to map heat sources to facilitate the utilisation of waste heat. And we would encourage planners to consider including wording on, supporting the utilization of waste heat where feasible in their planning documents, for buildings such as data centres and other industrial sites as well. And that's something that was done in the case of the South Dublin County Council as well, and kind of led to the scheme in Tala. And I suppose in terms of capturing it for bus shelters and traffic junctions, etc., I suppose it kind of comes down to what people see as useful heat. Is that using it correctly, or is it wasting it? And that generally translates to whether someone's willing to pay for that heat. So that's kind of another thing to consider. And I suppose kind of reflecting what's happening in the Netherlands as well. We're currently working on the Dublin Regional Energy Master Plan, which is looking at the kind of three main energy sectors, so heat, transport, and electricity, and kind of doing that, kind of assessing the certain technology options in terms of what's feasible, considering kind of spatial constraints and proximity and densities and all that kind of stuff that we talked about earlier, and also kind of the social impacts and kind of developing costed pathways, I suppose, to kind of decarbonize these sectors and kind of achieve our climate targets.
Okay, so from what you're saying is that the kind of planning for district heating systems outside of the usual suspects of the Nordics, where obviously district heating systems have been around for some considerable time, it seems to be playing catch up at the moment.
Yeah. And we're part of a project as well, an Interreg Northwest Europe project called HeatNet, which was trying to develop these kind of district heating systems in Northwest Europe, where traditionally there's less of a district heating market, I suppose.
Yep. So, as I said, there doesn't seem to be, as I said, planning seems to be catching up with what is available and technically feasible. But it feels to me like individual developments are being left to their own devices to decide how they provide the heat to their tenants or other uses such as offices or schools, etc. So, and I think this then points towards the edgy type of data center, which has become very popular over the last 18 months or so. Although some would say that it is just the old server room in your building that's been rebranded. So, Rolf, now you do a lot of work with HPC, and effectively your system is an edge data center, isn't it? So tell us a little bit more about how you use the waste heat with your solution.
Yeah, thanks. It's correct. We do a lot, and we focus a lot on this part of the equation as well. Indeed, although I have to make a remark. There is HPC and there's high density. There is challenges when it comes to density and high performing chips. The term HPC here, I'm not overly convinced that HPC by itself is a solution. We just need to elaborate a little bit on that, because HPC, high performance computing, tends to be focused on squeezing the most out of a chip, which means that if you can get more out of a chip by lowering temperatures, you're going to do it, right? So the goal of HPC is not necessarily to operate at higher temperatures. So high density computing, on the other end, is, and that's a different piece of cake entirely, right? So if you're looking at high density computing, which is associated with all the common cloud platforms these days, but also gets into the realm of AI and machine learning, when the goal is not necessarily to squeeze out every megahertz out of a CPU, but especially when things are focused on efficiency, that's where the edge talk really comes in, the edge equation comes in. These web-enabled platforms they can run virtually anywhere. So all you need is a proper data connection and a resilient design regarding edge locations, edge facilities, where you can apply geo-redundancy or have multiple sites in the edge that you can literally roll out. So yeah, I do like the reference to rebranded server rooms because it does feel that way. With one fundamental difference: this rebranded server room is not there to facilitate the company that it's housed in. It's actually part of a decentralized data center architecture, or actually not even a data center architecture, but an IT platform architecture. And this is how the holistic approach fundamentally changes that perspective and the way that you look at these things. So a lot of people tend to get stuck in the idea that we're talking about data center heat. We're not talking about data center heat. We're talking about IT equipment heat. And that IT equipment facilitates a platform, not the data center. And the data center is there to facilitate the IT. And that is a big impact. So if we're looking at the type of edge, the way to utilize the edge, there is a big benefit in looking at edge the way that edge is meant to be used. And that is the fact that you're deploying these heat generating platforms near end users, near heat end users, right? With all these platforms, we want to push them as close as we can to people, because people generate data, people utilize data, people use the platforms. Where people are, that's where you need the energy, that's also where you need the heating, right? And these edge platforms are being heavily accelerated by the current movement towards 5G, which is multiplying the amount of data that needs to be processed, the enablement of artificial intelligence, the enablement of instant data, instant anything, right? And combining these platforms with heat only makes sense. And that is very important to do, in my opinion. If we want to decarbonize the industry, let's not get stuck with the term data centers, because data centers are only serving their customers. We need to decarbonize the IT equipment that is inside, and when we do that, we are suddenly liberated from how we're going to utilize it and where we're going to utilize it. And designing for that purpose is probably key in moving forward with any kind of decarbonization agenda.
Okay, thank you very much for that. Nicholas, I mean, effectively your solution is multiple edge. And I was wondering, you know, how is your customer base looking at the moment? Are you seeing lots of interest in your solution?
Yes, we do. Fortunately, we do. What is great with IT is that we can move the heat as a digital information wherever we want. So it's really a strong strength that is really important, including for the customers. So by moving to the edge, we are moving the heat and we are moving the access point. So we are connecting all to the heat customers, but also we are moving closer to the digital, the cloud customers. And we have many applications where the building, for example, as an intelligent and a smart entity, will come to use the local resources that are at their disposal. So it's interesting to see that there is many more applications, heat applications that are developing. Every time we go on TV or on radio, we got some calls from many new customers that are thinking to new applications. Some of them we can do, some of them we cannot. But what's interesting is that everybody is looking for renewable heat, and moving the heat directly where it's necessary is really important for these customers. And we can just add more applications than district heating or housing heating, but the agriculture, the food industry, and the swimming pool. The swimming pool is the most common example, and we are seeing this example a lot of really often. But we consider a data center that is far from a heat district network. We can imagine really a lot of applications in the food industry or in the agriculture sector.
Great. That's really good. Thank you. And Alan, I've visited your facility up there in the cold wastelands of the Arctic Circle, and I believe I blogged about it, and I actually said it was really a hyper edge facility, which I would kind of consider to be a hub that other edge would connect to because of its size and its construction. So can you just give us a bit of an overview on what you're doing up there? And I noticed recently that you've connected your waste pipes to some biomass dryer. Is that right?
Yeah, that's correct. Well, basically, the Bowden Type Data Centre is an EU-funded project to build a 500 kilowatt data centre utilising fresh air cooling, divided into 3 pods, one open compute, one of GPUs, and one of ASICs, application specific, quite rare thing, Bitcoin miners. So what we've done with the Bowden Type Data Centre is tried to maximise efficiency of air cooling and the overall infrastructure. And by doing a few things, we have actually been able to achieve a PUE, a partial PUE on the cooling side, of less than 1.01. And our record's 1.003. So very good numbers. But one of the key spin-off benefits of having a very good cooling efficiency is that we create higher temperature exhaust air. So on the ASICs, where I've got control over the chip temperature control algorithms and the fans on the ASICs, I can achieve a hot aisle temperature of 50 degrees centigrade. That temperature suddenly becomes useful because it's all about trying to avoid this this requirement to do something, a secondary process. Just also to do with Bowden as well, we've been talking about density. What we've also done with by increasing the efficiency is the density. So we're now running at the equivalent of 60 kilowatts per rack on GPUs and ASICs with just fresh air. And we're also able to run at temperatures with air on temperatures up to 35 or 40 degrees centigrade, which once again challenges why we need any other form of auxiliary cooling, be it refrigeration or adiabatic or whatever. Okay, so one of the key spin-offs of this high temperature air is we said what we're going to use it for, because we don't have the benefit of being alongside a community or a big building which can use the heat. We've also got a large dilemma that we make the waste heat at exactly the wrong time. We make it the most heat in the summer, which is when any district heating season needs the least amount. And we also make the most in the middle of the day compared to at night time when people want it. So one of the challenges is how do you buffer this heat? And we're talking tremendous quantities of heat we might have to buffer. So we took this idea and said, hey, hang on a minute, suppose we dry biomass in summer and during the day and use the biomass as a buffer that people then can consume in whatever heating scheme they want. Okay, so we're just doing a trial now with a Finnish company called SF Tech, where we've got a containerized biomass dryer alongside the data center, and we're doing a series of experiments where we're taking standard data center temperature air of 30 degrees centigrade and trying to dry biomass with it. We're ramping up to the higher density 40, 45 degrees. So we're actually now in the last week of the trial. So hopefully we'll see some results published from the guys at RISE, the Swedish Institute of Computer Science, Torbjörn Mind and John Summers and his team. We'll be publishing that in a few weeks' time. Does that make sense, John?
That makes a lot of sense, actually. And we did have a question, actually, which I'm going to answer now, because it says, are there any commercial examples of data center waste heat usage for systems other than district heating? Example, agricultural usage. Now, I believe there is a data center in the Netherlands, and it might be an urban myth, but apparently it's next to a kind of farm in a greenhouse where the one of Amsterdam's most attractions is produced. I don't know if that's true, but I do know that there are some projects around that are planning to put the data center waste heat into greenhouses, which I think is a very good idea as well. Heat doesn't have to be for humans; it can be for other processes. We're running out of time, so we've got half an hour left. There are some questions I want to cover later on, so I'm going to combine the next two questions, which is all about the finances of district heating systems. And I think personally, they kind of need to be revenue neutral over what it costs for a data center operator to build their solution now. So there's two parts to this question: is does the cost of the equipment required to pump the waste heat into a local district heating system, is it very much? And should, you know, data centers costing millions of pounds, euros to build, is the cost of the heat pumps and the necessary pipework a relatively small thing within that cost, that overall cost? And the Catalyst project has developed a marketplace software suite that includes some incoming revenue models from the sale of waste heat. But I think the concept of a heat market is some way off. So I'm going to restrict this now. So, John, can you give us an overview of how much you expect to pay or what the costs are for the district heating system in Tallaght?
Yeah, well, I suppose the district heating system itself is somewhere in the region of 5 to 8 million, and you know that's kind of paid through a number of ways. I guess there's money provided by the council themselves. There's some grant funding from the Climate Action Fund. There's some funding from the Interreg Northwest Europe project, and then capital provided by the ESCO, who are going to design, build, operate, and maintain the network. And essentially, it's a not-for-profit public utility, the first one in the country. So, I guess the main requirement is that it can wash its face within the contract duration, which is 10 years, and then any excess margin will be reinvested into the network to maintain its kind of efficiency and expand it. I suppose in terms of value for money, I suppose it did secure about 4.5 million Climate Action Fund funding, which is based on a sort of a euro per CO2 abated sort of metric, so it's good value for money in terms of CO2 abatement. For the waste heat itself, the data center itself actually provided the waste heat for free, so I suppose they kind of saw the value in it on their side in terms of providing free cooling, kind of feeding into their corporate social responsibility, so kind of having a more tangible kind of local benefit than, say, like a PPA might have, where they're kind of seen in some quarters as a sort of an accounting exercise that some people might not trust for whatever reason. And I suppose the kind of ability to reduce kind of on-site plant requirements, so the space and costs associated with those. And reduce required capacity charges on the electricity, and in the case where it's evaporative cooling, reducing water consumption. I know the price of water in South Dublin is something like €2 per cubic meter, so that kind of adds up over time as well. And then I suppose they had the kind of additional carrot, I suppose, of having someone whose primary business is to monitor the heat recovery, which kind of allows an extra set of eyes, I suppose, on their cooling system, and kind of an early warning to any issues that might be occurring there.
Okay, excellent. Ero, can you give us just very briefly, can you just tell us how much the Telia building cost in terms of its district heating pumps and its ductwork, very roughly?
Well, I can't go into the exact numbers, but
Yeah.
of course we are talking about some millions, both on the district heating side, because they need to build a new connection pipeline to the data center, and investing into the heat pumps will be also, let's say, a couple of millions euros. But we are looking to a, let's say, agreement period of 20 years. So
Okay. Yep.
it's not that much in that time of period.
Yep. Right. Okay. I'm now going to ask Eric a specific question, and he knows this already because I've told him that I'm going to ask him this. So famously, back in 2016, the Dutch Data Center Association said that all of its members were planning to give away their waste heat for free, but there was a caveat. Whoever wanted to use it had to pay for the infrastructure to come and collect it. So has that policy been successful? And do you think you may have been a bit premature in the free part, considering that it does seem to be that there are some there are some revenue earning opportunities from the use of the waste heat?
Good question, and yeah, it's true. In 2016 or 17, it was actually my manager Stijn who made this remark. So this is still the current case, right? We still offer our waste heat for free, which is always a bit difficult to say, because like Eero said and all the others confirm, there is a need for investment at the data center campus. The piping needs to be in place, and somehow there needs to be a demarcation between the district heating operator and the campus of the data center. So the caveat, or whatever you would like to call it, is that we provide the waste heat as is, right? So at the current temperature, we don't deploy any heat pumps to upgrade the temperature or whatsoever. That is the responsibility of the district heating network operator. Obviously, we as a data center, they need to invest, like Eero and everybody confirms. The business case is built on obviously the reduction of the electricity bill for cooling, because in return, the data centers in the Netherlands expect somehow a cold return from the district heating system, which will potentially reduce the energy bill of the data center itself. However, the data center itself, as you know, data centers are all about continuity and security. They will always have their own cooling system on the rooftops, because like somebody else said as well, we generate most of the heat when the heat is least required in summer. So yeah, we are also thinking about, and I think the drying of the biomass is a nice idea, but we're also thinking about how to basically store the energy or the waste heat energy. So the situation is still true. It is successful, but like I said in my earlier remark, it does make the business case for the district heated network operator somewhat more difficult, because they need to upgrade the residual heat from 30 to whatever temperature they like to have.
Yeah, I'm just going to come in on that. So as the part of the Catalyst project has been one of the consortium members is actually Aliander, and I spoke to Aliander a couple of weeks ago and said, look, what type of district heating are you planning to put into the Netherlands and specifically Amsterdam?
Yep.
And the reply back was, well, there's three different types of district heating systems. There's the high temperature systems, which are used in the Nordics. And the reason there is because the average temperature is so cold and they have, minus temperatures in the wintertime. Then you have medium district heating systems. And then there's low temperature district heating systems. And I feel that in the Amsterdam region, especially, you can probably get away with a low temperature district heating system. So the heat required to boost or the temperature, the equipment required to boost the temperature isn't going to be that much. Okay. And they can operate at 20 to 25 degrees for underfloor heating systems in the houses. Right, that's that point. We're running out of time. We've got 20 minutes left. We have some questions. And there's one question that's come in from a panelist, from a delegate. So I really want to answer this one because I think it's going to be quite interesting with the responses. So a couple of days ago, or a couple of months ago, a certain large cloud-based company pulled out something called the Project Natic out from Orkney. And I've been tracking this online. Actually, some of the questions that have been coming out from it. And one guy says, I can't understand why they think this is a good thing, because surely they're heating the ocean up. So can somebody just say something? I'm just trying to find the question. So, any feedback on Microsoft's data center in the sea? It made headlines recently, but I'm not familiar what they did to keep it cool. Can anybody tell us how they kept it cool?
As far as I'm aware, it's being cooled with seawater, which is very efficient, of course, from a data center perspective, solving the heat problem for the data center. I'm not too sure about the impact for ocean warming, but one of the things that is relevant to consider here is the fact that the electrical energy is wasted just the same way as data centers are commonly operating, by exhausting all that thermal energy into the air. And the whole point of efficiency is that to carbon neutralize something, to make anything carbon neutral, whatever your waste product is going to be, you need to focus on making it usable. And putting something on the bottom of the sea will not provide that opportunity. So that's the thing I can say about this. I don't know if anybody else wants to chip in there.
No, I fully agree, Rolf. The whole idea is to reuse the waste heat of the IT equipment, whether it's locally by Carnot, or whether it's in immersed cooling, or whether it's in air cooled. It doesn't really matter. But to waste heat into the ocean, I don't believe that solves anything, to be honest. But I don't know all the details. I could imagine that there are some other technologies in place which will make it more efficient. But at the end, electrons generate heat, and as long as we don't have some futuristic computing technology, I think we should reuse the heat as good as possible and not waste it into anything, either water, air, or space. I don't know.
No, and I would tend to agree. In fact, I discussed this with Derek Webster, who's a well-known data center strategist, used to work for Yahoo, and he told me that they actually investigated this back in the early 2000s, and it was just purely a method of not paying any tax. Right, because the seabed is international waters and you don't have to pay tax. And that's what he said. And I can't think of any other reason why you'd want to create a marine grade tube, plonk it full of air-cooled servers, pump it full of nitrogen, and then dump it into the ocean, regardless of whether it's not it's using renewable energy. Now, the thing there is that unit was supposed to have a 5-year lifespan, and they pulled it out after 2 years. So I don't think Microsoft are telling us the whole story on that. But right, let's continue with the questions that we've had. Right, this is from John Miranda, who's Director of Data Platforms Group Strategy for Intel. And he said, what liquid exhaust temperature will help tip the edge? And I think that question's for Rolf.
Obviously, I'd love to answer that one. So if you look at the real value, the tipping point for really breaking this status quo is for data centers to generate anything in the range between 50 to 70 degrees directly from the water circuit, right? So if that can be achieved, then you get to the tipping point where all the utilities would love to jump in and come and pick it up from you. With the reference to a couple of years ago with the announcement, well, come and pick it up for free. Well, yeah, that's great to do if it's, and it's a great way to get rid of the return temperatures in traditional data center builds. But if you really want the utilities to start investing, this is what you're going to need. And you're going to need to be able to provide that. And combine that with a minimum base load equation as well, right? So as in making sure that from the utility point of view, from the heat grid point of view, the data centers can provide a base load so you can reject that heat year round, and then you can start making some real disruptions. Then you can be part of that heat grid ecosystem.
So what temperature? 50 to 70?
Between 50, as soon as we can continuously deliver 50 degrees Celsius of heat directly from the data center, that's when it starts becoming, that's when you reach that tipping point. So up to about 70 degrees, 70 degrees is pretty much the holy grail. Then you can distribute that directly. You don't need to mix it. That can be a temperature that can be utilized, and is worth a lot of money.
Okay, excellent. Right, I'm just gonna give single answers now, unless somebody really wants to butt in on it. So, is the sector exploring alternative funding to access energy efficiency? And that's from Paul Boylan, from the technical director of Vivid Edge. I would say that the big colo players are basically self-funding, and they're forced into making decisions on district heating via the planning permissions. But there is also we await what comes out from the EU Green Deal, and of course there's Innovate UK in the UK that is providing some funding for data centers, but you have to dig down and find it. It's quite difficult to find. Okay, so this question is from John Breen, he's a technical project manager at Amazon. When will we be carbon free by design?
John, I think you muted yourself, John.
Yeah, I did. Yeah. So, John, when will we be carbon free by design? Yeah. Okay. Well, we'll be carbon free by design when all of the back office staff and the designers of data centers have access to products and techniques and concepts that will allow us to be carbon free. At the moment, it's very much largely offset. We're not really even scoping or finding out what our scope 3 emissions are in terms of GHG protocols. So let's wait and see on that one. I don't think it's going to be imminent. Okay, then. So, Mr. Cowan, yes, Eric, please.
Yeah. So, carbon free. So we need to define what is carbon free from a data center, right? I mean, because in the Netherlands, I think 90% of the electricity used by data centers actually is sustainable and is not generating any carbon. From an energy perspective, but there's of course the building, there's the IT equipment which is being built. So what is the definition of carbon free for the data center industry? Is that including the building, or are we looking at the electricity, or are we, is there a definition in Green Deal?
Eric, I think that it's everything. Nicholas?
I think maybe one of the first steps to go through before we become carbon neutral is to make sure that everyone is aware about the carbon footprint of the hardware and of the energy. So I think it's maybe the first step, and we are going through it, and I'm sure we are not alone.
Okay, John?
Yeah, it's sorry.
John, one thing that I've been investigating at Bowden Type Data Center is actually getting a meaningful measure. And we started measuring energy input per processing operation, because we can currently run an efficient data center or carbon neutral data center, but still be very inefficient at processing. Okay, so I think we need to take a deeper view on our measurement and what we're doing and get some meaningful metrics of our processing activity. Does that make
absolutely. There's a lot of elements that in data center and carbon neutrality and carbon free that we have yet to explore as an industry, and I think that's a topic for another debate. So I'm going to.
How many grams per CO2 per trillion server-side Java operations?
Absolutely. Yeah. Okay. Right. Next question is from Patrick Evans, who's the MD of PD Evans Consultancy Limited. Latent heat from air conditioning heat pumps. How can this heat be recovered and used? I think that's already being recovered in certain cases. But Alan, have you got a view on that? Oh, Alan's disappeared. So, let's leave that one.
Yeah. Can you hear me?
Yes.
Can you hear me? I really see very little heat recovery anywhere in data centers, and I go in hundreds, if not thousands of them. Okay. You get a few people who will take some heat from the condensers and try and put it into buildings on simple systems, but really I see very, very little.
Okay.
Alan, isn't that because you're building air data centers?
No, I've got a lot of data centers which are just using conventional DX and chilled water systems. Really, the people do everything they can to get rid of the air, to get it away from recycling back into the condenser. And this applies on big indirect systems as well. You know, the giant Colt units in X-Cools, just the same. It's very disappointing. We do, as a cooling guy, we do a really poor job.
Okay, we're closely running out of time, and there's a few more questions that I would like to ask. So this one is from Greg Shannon, the chairman of Shannon Energy, and he says, "Are any corporate PPA contracts being negotiated?" I'm not quite sure what that question means. So I'm going to pose this to John. Obviously, is your data center client for Talect, are they negotiating a PPA with the ESCO?
I'm not sure. It's kind of something we haven't looked at in any great detail at the moment. We're kind of concentrating more on, delivering a system that's as efficient as possible. I guess what I would say is, with PPAs, they're obviously better than nothing, but the kind of greenness of the electricity used directly used by the data center will depend on the generation kind of breakdown on the grid at that time. So there's no special green electrons that are going to the data center. So it is in essence an accounting exercise, which is, open for criticism in certain quarters. What I thought was quite interesting actually was last week Google announced that they're going to be adjusting how they do their PPAs. So it's going to be on an hourly basis to try and capture that very, very thing a bit more accurately. But yeah, we haven't looked at it in any depth yet, but it's something we might consider for sure.
Okay, thank you. Right, this is from Hans Golden, who's the Director of Product Management at Novenco. Can heat reuse be a reliable cooling solution, or will it always require a second backup cooling solution to meet SLAs? I suppose that actually depends on what your SLAs are. But Nicholas, in your distributed compute architecture, do you need any additional cooling in your actual site?
No, and it's forbidden because we are also under the regulation for buildings, and we demonstrated that it was waste heat, but they asked for forbid cooling from this building, so we don't have additional cooling. Nevertheless, it's important to be able to handle and to leverage the heat produced and to move maybe the heat produced, and that's what we have done in Catalyst project, relocating the virtual machines in other places where the heat is also requested. So there is many alternatives to the cooling if you want to use the heat at the building level.
Excellent stuff. Right. Okay. from James Nolan, the engineering director at Frontline Energy. And we picked this out actually earlier on. So the question is, if modern processors work up to 49 degrees C, why not use the ambient air in data centers, ambient air in Ireland to cool data centers? I'm going to point that towards Rolf. So if you could just give us some idea of exactly what temperatures chips operate at, and then answer that question.
So this temperature that's mentioned, that's usually referred to as an idle temperature. That's not a workload temperature. So CPUs on the case, they actually operate ranging somewhere between 60 and approximately 85 degrees C. Internal temperatures within the chip, they can get up to 100, 115 degrees. Then we're talking about core temperatures. So that's on the die, that's inside the die usually. Now, cooling that with ambient air temperatures, yes, of course, that's the whole. That is exactly is the point. The difficulty is if you utilize air for that purpose, air is not so easy to cool with. Actually, regardless of the fact that we're all doing it, but air is not the most effective medium to cool something with. Imagine, for sake of argument, imagine taking a glowing stick out of a fire, right? So there's two ways of cooling that. One is to blow on it, and the other one is to just stick it in a bowl of water. Now you guess which one is more effective and which one is more efficient in heating up the medium that you're using, and which one is more effective in keeping the temperature of that glowing stick down. And that's where the difference is. So if you want to be able to utilize ambient temperatures with current chips, especially the high-powered chips that are now flooding the industry from Intel, AMD, and any other, and NVIDIA, and all the other chip manufacturers at the moment, we're looking at thermodynamic properties of going up to about 300 watts. Last week, I even had a conversation with someone who mentioned that they were utilizing the chips. They wanted to utilize the chips up to 1,000 watts, and we're talking about the same size chips. I mean, that is going into the realm of impossibilities regarding air cooling. This is where air cooling can no longer maintain these kind of temperatures. John, you're muted.
Okay, so I'm going to take, I think we've got time for one more question, and I'm going to take this panel to everybody needs to answer it. So I think Eric basically said that they were looking at a long-term ROI on any heat stuff that they implement into their facility. And I just want a yes or no answer from everybody. So should we be looking at heat as a long-term investment, or should it be relatively short-term? So Nicholas.
I'm sorry, I don't want to answer yes or no, but I just want to answer something else. Actually, we are selling our hardware to the buildings, so they pay for our computing capacity. So then we can do many things by a cost structure that is really different, and we just have OPEX at the end. So it's really a matter of a business model.
Okay, Rolf?
Yeah, it takes a while before the mute goes off. Both. It all depends. I agree with Nicolas here. It depends on how if you're building a data center, it's a long-term investment. If you're working with the compute capacity, it's a short-term payoff.
Eric?
Yeah, I tend to go for the long-term answer from the viewpoint of a data center. So I would say long-term. I also see contracts which are actually longer-term, which are 20 to 25 years.
Eric, we know your answer because you've already told us about it.
Yeah,
with Telia, very long term. Alexandro, obviously.
Yeah, I mean, district heating is a long-term investment, but let's say that once you have the network, you can use the waste heat from a data center, and the day the data center is no more there, you can use it maybe from something else. So it depends. Once you have the infrastructure, you can use a lot of sources.
Okay, John, obviously the same from, you must see it as a long-term investment in there. So, and Alan seems to have gone offline again, so we can't ask him. So thank you all for joining this session on the topic of heat close to the edge. And I think from all the panelists that we see huge opportunity in the reuse of data center waste heat, and that there are still some, what I consider to be minor difficulties to overcome. And I'm sure we'll see some movement from the European Commission in the coming months to smooth out some of these wrinkles as part of the EU Green Deal. So I'd like to thank all of the delegates for their time and input today. And I'll hand over to Hugh and Kirsten to wrap up and tell us about the next Data Center Ireland event.
Thank you, John. And can I say thank you to all the panelists for their time and their knowledge. I found the discussion incredibly interesting. And I know there is a lot of other chat questions that were in the chat room that we weren't able to get to. What I might do is send those through to you, and if you have the opportunity to answer them, if you feel that you should, I'd be grateful. I just want to let you know that Data Centres Ireland, obviously due to the pandemic, can't take place this November, and we've postponed the event through to November 16th and 17th, 2022, where hopefully we're all physically will be able to sit round with a pint and of Guinness, I hope, and enjoy each other's company. But on behalf of Data Centres Ireland, I, as I say, like to thank John for his hard work and the panel for coming on. With that, gentlemen,
Hugh, did you mean 2021?
Did I say 2022?
You did.
Oh, good grief! No, that's please no. My cash flow won't get me through to 2022, 2021. Anyway, apart from that, thank you all very, very much. And yes, with that, we'll put this up as a recording on our website. So on behalf of Data Centres Ireland, thank you all very much, and I hope you have a good day. Thank you.